Hey friends, welcome back. Now we are going to learn the batch processing, which is a preferred optimization technique as well. We need to learn in depth about batch processing. We have already seen a couple of techniques like the pruning, and I hope you enjoyed it. What is batch processing and why is it important? Batch processing is a widely used method for addressing performance issues. This approach involves grouping multiple inputs into a single batch for concurrent processing. That means bringing many items together to process. Optimizing hardware usage and increasing throughput is the major task that we can achieve through this batch processing. It's a strategy that processes numerous data inputs simultaneously rather than handling each one separately. In the advances of the AI, we are seeing a lot of advancements that are happening with AI, machine learning, deep learning. Batch processing is a superb method that allows models to handle a set of inputs such as images or text at the same time. This method enhances efficiency and accelerates overall compute. And most importantly, the benefits are plenty and appreciable too. Performance enhancement is the first one. Batch processing combines multiple inputs for simultaneous processing, contrasting with the traditional single input approach. This method minimizes overhead by utilizing parallel processing capabilities. That's a great thing for AI. Next is maximizing the resource usage. This technique effectively keeps CPUs and GPUs occupied by processing multiple bundled inputs concurrently, representing the ingenious approach to resource utilization. This is a great thing for resource utilization, and I am certain the results will be visible in front of you when you follow this. Then comes the increased output. As a result of doing batch processing, following batch processing technique, the system becomes more efficient, which will also be capable of handling larger volume of data per second. This leads to higher number of completed tasks with the same time frame. And finally, decreased processing time for large-scale operations is another advantage that we bring on the table. For operations that don't require instant feedback, such as the video or image classification, batch processing significantly shortens the overall processing duration. That's a great thing, right? People who work on that will definitely relish it. Let's take a scenario. To better illustrate and understand the concept, let's consider a scenario where we are involving 100 images that need classification using ResNet model. Without implementing batch processing, the model would process each image individually one at a time. This approach would lead to a lot of repeated overhead and inefficient resource utilization. By employing the batch processing, concurrent inference becomes very much possible. Images can be grouped into sets of 10, allowing the model to classify multiple images simultaneously. This method reduces the overall processing time by enabling the model to handle several inputs at a single pass. And most importantly, the batch size now comes into the picture. How do we set it up? Batch size, when it is set as 1, it is single input to be processed at time. Batch size, when it is set as 32 inputs will be processed in parallel. Batch size, when it is set as n inputs are grouped and processed in parallel. What would be the ideal batch size? Any guess here? It depends on the factors which include the memory availability and model complexity, etc. Larger batch sizes lead to faster throughput but may increase the memory usage, which is a concern that we need to work on. Always a practical example is going to be very helpful, and I am providing you one here. A practical example is good to try as well. I will give you the link for the code which I have already uploaded in the Git. You try it out yourself. The provided example is a very simple one for understanding the batch processing for image classification using pre-trained ResNet 18 model with PyTorch. It retrieves multiple images from URLs, applies necessary transformations such as resizing and normalization, and then processes them collectively in a single batch for inference. By combining the images into a batch, the model efficiently categorizes all of them simultaneously, thereby optimizing the CPU and GPU resource usage and reducing processing time compared to individual image analysis. The code is very simple. It incorporates the error handling to bypass invalid or inaccessible URLs, thereby ensuring consistent and continued execution even if some images fail to load. Following the inference, the model's predictions are translated into human readable labels which you can see. It's a very simple code which I have presented and we can walk you through that right now. We have used PyTorch as you can see right in front of you. We are doing all the necessary import. The next step is to load the pre-trained ResNet 18 model. We are loading the ResNet 18 pre-trained on ImageNet and then we are setting the model to evaluation mode. Well, the second step is very interesting where we are getting the image URLs for batch processing and we have given a list of valid image URLs and we are going to classify cat dog. The third step is interesting and important too. We will do the necessary transformations and the transformations and the processing include resizing, converting to the tensor and normalizing images to fit ResNet's input format. Once done, we will download and transform each image. I have also included a point earlier when I spoke about we are going to skip invalid and unreachable URLs. So that's all done in this part and it's going to be very simple and easy to run code. And then we will go ahead and perform the inferencing on the batch. I use the term batch here instead of single image. That means we are getting into batch processing. Then we are getting the top predictions for each image. We are going to get the ImageNet class labels. And then finally we are going to map it such a way that you and I can read it. And the output is presented right in front of you and that's very simple. You can scan this QR code to get the code from the GitHub and that way it's going to be very helpful for you to run and see if you can get the same result. Try it out and let me know if things work. Thank you very much for following this channel and the content. If you like the content of the channel, please subscribe.